What if I told you that you could write 60% less error handling code, making it impossible to forget error checks and zero performance cost? I am Xavier. I'm going to show you how railway-oriented programming transforms messy, error-prone C# code into clean, readable pipelines. Let's look at a real example. Here's what most of us write today. Notice the pattern. Validate, check for null, return the error code. Over and over and over. Over 20 lines of repetitive error checking that obscures the actual business logic. And now here's the same functionality with railway-oriented programming. Just 8 lines, and it reads like English. Create first name, create last name, create email address, create the user, check if the user exists, save it to the database, send welcome email. And if any of those steps fail, the rest are automatically skipped. No more if statements, no more forgotten error checks. Let me show you how this works. Before we dive into the solution, let's talk about why traditional error handling in C# is painful. Problem 1. Repetitive boilerplate. Every time you need to validate input, check a database, or call an external service, you write the same pattern. Perform operation, check for errors, return early if failed, or throw exception. It's verbose, it's boring, and it's error prone. Problem number 2. Easy to miss error cases. In a rush, copy paste some code and forget to add the null check. Congratulations, you just shipped a null reference exception to production. Problem number 3. Primitive obsession. When everything is a string, the compiler can't help you. Swap 2 parameters by accident, it compiles. You don't find out until runtime, or worse, when a customer reports it. There is a better way. Let me introduce you to railway-oriented programming. Railway-oriented programming is based on a simple metaphor. Imagine your code is a train traveling along railway tracks. You have 2 tracks. The success track when everything works, the error track when something fails. At each operation, validate input, call database, send email, the train either stays on the success track if the operation succeeds, or switches to the error track if it fails. Once on the error track, the train stays there. All remaining operations are automatically skipped. This means you write what should happen, not what could go wrong. Now let's look at a sample of creating an ASP API using the FunctionalDDD library. So in this sample, we need to include the FunctionalDDD libraries, and the NuGet package that is needed are the following. The railway-oriented programming uses the H result and the core functionalities like bind and tab. We will need common value object generator since we'll be avoiding primitive obsession in our code. So things like first name, last name, instead of using strings, we are going to actually create a strongly typed class called first name and last name. This has multiple benefits. One is the compiler is able to check if you're passing last name instead of first name. And when you're using AI to generate code, it allows AI to reason about the code much better. And if AI by mistake also passes the wrong parameters, the compiler errors will help it catch those mistakes and correct itself. So when possible, try to avoid primitive types. First name and last name are value type objects, so those classes will be derived from value objects. So we need the domain-driven design library, which gives us the value objects and the aggregate. In our case, will be the three value objects we have: first name, last name, and email address. And then we will also have an aggregate called user. Email comes from the common value object, so we include that class. And then in the aggregate, if you were to write your own the validation that you need, you can use an external library called Fluent Validation. It does a lot of features that helps you write validation code, and that can be to convert the validation errors from Fluent Validation to the validation error in FunctionalDDD. This particular library helps you do that translation. And then we have the ASP, which is converting the the result object to the HTTP error codes. Okay, with that, let's take a look at the project. So here we have the FunctionalDDD libraries added in from ASP. So these are the ones that we need. And then we can start creating our own classes. So all we need to do is create a class called firstName and derive it from required string. Make sure it's marked as partial so that the source code generator can go ahead and create all the other methods like try, create, serialization methods, and so on. So from a developer point of view, this is all that they're required to do. Similarly, we are going to create last name. Then we have the user aggregate, and the user aggregate has 3 value objects: our first name, last name, and the email address. The specific email address is coming from the common value object DLL. And here we can see that to create in domain-driven design, whenever you create an object, it's always supposed to be valid, which is why the constructors are private. And you have this try create method, which will call the validation logic. And if it's valid, it will create the object and return it out. And the validator here is using that external library called Fluent Validation. It gives you lots of other functionalities like maximum length and regex match and so on, right? I would suggest just check out their documentation. And once we have our aggregate, we are ready to use it in our controller. So we just have one method here, which is register user. And the register method takes in the request. Request has 3 parameters on it. And at this point, they are just strings, which means people can type anything they feel like, including empty strings. So the first part is each of these properties, the value objects, the try create method is called on it to see if that particular string can be converted to the respective value object. And if the validation passes, you end up with a successful value. And if it fails, you end up with the validation error. The combine method takes care of combining the results from these multiple outputs into one. So in case of success, it'll combine them. We'll have 3 values coming out of it. So that'll be the success track. And if it fails, we'll have an error object with the single or multiple failures. And then it'll take the failure track, go to action result, and it'll return what the failure may be, whether it's validation error or here if it's conflict. Okay, with that, let's just see it in action. So let's just run the project. And we have here one single API. Okay, so the first time I'm gonna call register, pass an empty string for first name and an invalid email address. So we should get back error with validation failure of 2 objects. And here it is where it's saying first name and email addresses are not valid. It's using the problem detail object from the ASP.NET Core. So it'll give you the right in the RFC 9110 format. If you were to go to a browser and paste it in, you'll see it's taking you to the right section saying it's a bad request. Now, next, so here we saw the combine, that's combining the error of the first name and the email address and giving you a bad request. Next scenario, it's going to be all these properties are valid, but this email address already exists. So what's going to happen is once the user is created, you'll try to check in the database. And since it already exists, it's going to return the conflict error. So let's see that in action. So here we are with 409 conflict, and there's the error message. And again, this will lead you to the right spec. Right, so there it is, conflict. So you're getting all these functionalities, but not really having to write the code for it. The FunctionalDDD library takes care of these translations for you. Next, let's create a user for success here. Now Jane Doe is created and it's gone through a success path. So you get 200 HTTP 200 from the API. This is a scenario where we were on the success track through all these function calls. And when we ended up to action results, it gave us 200 and it converted the domain object to JSON and sent over the result. So that's kind of the main scenarios and functionalities. And if you look at it, we'll see, you didn't have to if you were to check results after every such call, there will be a lot of repetitive code and it'd be hard to read. Here's straightforward. It's kind of just line by line. First is try to create the first name, then try to do the second last name, email address, and combine the results of it. And if it's successful, go create the user. Once the user is created, ensure that it doesn't already exist. If it does not already exist, save it to the database, send a welcome email, and then send the response back to the caller. On the other hand, if one of these things failed, it'll take the error path and return the respective error message. So you kind of reduce about 60% of code by using this style of coding, railway-oriented programming. I'm just going to show you some additional variations of the scenarios. Here we're going to call register user, but all the 3 parameters are wrong. So we expect to see validation failure, and our errors should tell the fields that failed and why it failed. So we have that information here. And here's a scenario where only the email address is wrong. So we should just see that one error result. There it is. And finally, let's go create another user, Alice. And here's Alice. Since all the validation passed and this email address does not exist, it was successfully created. So let's recap what we have accomplished here. Type safe domain model. Compiler catches parameter mistakes. Automatic error aggregation. Show all validation errors at once. Business rule enforcements. Email uniqueness check. Side effects. Database save and email sending. Automatic HTTP response. No manual status code mapping. Zero performance overhead. Literally 11 to 16 nanoseconds. All in 8 lines of code that reads like a story. Want to try it yourself? Here's how to get started. Create a new project. Install the NuGet packages. And I also have several documentations on xavierjohn.github.io FunctionalDDD. And if you click on the articles, I have also given this. You have the basics here, and there are several examples too. If you like the project, give it a star so others can also discover railway-oriented programming. Railway-oriented programming isn't just about writing less code. Though 60% less boilerplate is nice, it's about writing better code. Code that reads like English. Code where errors can't be forgotten. Code that's easy to test. Code that's easy to maintain. And you get all this with zero performance cost. I am Xavier. Thanks for watching and happy coding.